Page 15 of the C programming notes. So I've shown you the tool chain. Often you just interact with an IDE like Microvision 5, but in the background those are the programs that it's using to build your program. So moving on, let's just talk about what happens on the Kyle board when you start up a program. And this will be a bit different than starting a program on a laptop or desktop, but there's a lot of similarities. So with the Kyle board, when you power it up, or there's a reset button, if you press that and release it, it's going to reset the processor and peripherals, and it'll hold the reset signal for 1 or 2 clock cycles, and then it will release it. In the lab, basically you can just reset your simulation and you get the same effect this term. So on power up or system reset, the reset underscore handler runs. We're going to talk about handlers in the section on I/O, but they are interrupt service routines essentially. And this particular handler is found in startup underscore lpc17xx.s. So it's defined in assembly language. .s is an assembly source code file, which is part of the setup code that you generate when you configure your project. So the reset handler runs, and so let's just look at what the reset handler does. So the first thing it does is it invokes a function called system_init. So you can actually look at that assembly file and you can find the reset handler in there, and you can see it invoking these functions. And what system_init does is it sets up the basic hardware for you. So it initializes the clock, and it powers some peripheral devices. I suppose the analogous thing on a desktop system would be BIOS. Okay, once system_init returns, then reset handler invokes something called main, but is prefaced with a double underscore. So when you see a double underscore in front of a function or a variable, it means that it's library code and you probably shouldn't be touching it. You shouldn't be trying to call it directly from your code, even if it is possible to do so. So if you look at the code for main, or if you step through it with the debugger, which you could do, you'll see that it calls something called scatterload. This is also found in the Kyle documentation, but you have to really dig to find it. What scatterload does is it loads your instructions into your text segment, and it initializes the data segment. So it loads instructions into the text segment, and that is in Flash in our configuration, and initializes the data segment. And for us, that's located in the static RAM. So that's the memory that we can read and write as we're running. So that's where we need our global data, and our heap and our stack will also be located in SRAM. After that returns, double underscore main invokes runtime entry, double underscore RT double score, or sorry, single underscore entry. And this, so I referred to this before when I was talking about libc, and so this is part of libc, at least in the Kyle setup, and it initializes the stack and the heap. So it sets, in the case of the stack, it's going to set the stack pointer register to point to the bottom of the stack, and usually it will, if you're running from the command line, it would put like argc and argv, those command line arguments, onto the stack for you. Not in our case, because we don't have a command line. And the heap, it will initialize some static or global data structures that are used by the malloc library. And once it's done that, we're ready to go, and it runs your code. So, and invokes main. So that's how you get from resetting the power on your board all the way to your main running.